So we're at the top of the site at Moonstone, and we are looking at what is a 20,000 litre storage tank. Now all that water is recycled, so we collect first of all rainwater from our driveways, from the curved roofs for gull wings. All that is rainwater. We've chosen to have hard surfaces so we can collect through channels all the runoff water from the rain, etc. And then we also recycle our water from sinks, showers, bathrooms, toilets through our reed bed system and pump that recycled water back up to this tank. And the tank is also topped up by a spring feed, which is some 350 metres away. All the water has to be processed. It goes through a UV filtration system, a nitrate filtration system as well, because we're in that open countryside and there's a lot of farming around us, so you get a lot of nitrates from fertilisers, etc. So all of Moonstone is basically off-grid, not only from electricity and heating perspective, but also from water, and we'll see later on from sewerage as well. So we collect all the water we can and we reuse it, constantly reusing it. The entire Moonstone house, or Moonstone project, is heated entirely by solar thermal panels. There is a backup of a small NIBE heat pump, but principally everything comes from these rather large 3-metre high panels. There's 50 square metres, or approximately 50 square metres of panels, which are heating hot water. Now today is a dull November day, 12th of November. Although it's very dull, it's not an ideal day for it. We'll be kicking off around about 50 to 60 degrees of temp of water that we can heat our pool, heat our house if necessary. The 80 to 90% of our heating comes directly from the solar thermal panels. So water goes through a crisscross mechanism of pipes, picks up the heat. We're in November now, 2020, and all these panels produce so much heat, but one, we can't use it for our sinks and taps and baths, etc. So we dump it into another heat reservoir, which is our swimming pool. So this entire system is heating a swimming pool and a 17,000 square foot house for free. Job done. So Moonstone has 5 pieces of 100mm extruded polystyrene insulation, which is totally waterproof, to give us a U value of 0.06, which is twice as good as current passive house standards. This is obviously a very thick wall and not necessarily appropriate for all types of houses, but this product is now, as technology has moved on, being replaced by products everywhere from Vacupor 10 to 15mm thick, which do roughly the same sort of job as this amount of insulation, called aerogel. So throughout the duration of the Moonstone project, we're constantly using innovative new technologies, LED lighting, etc. But as I said earlier on, one of my favourite technologies is actually insulation. So we have now a live experiment working. We've taken what is basically an octagonal Swedish barbecue lodge, and we've basically only put one single bit of insulation in that shed. So we've used a product called aerogel, which is approximately a 10mm thick product, which is waterproof, vapor-proof, and the insulative value of that tiny bit of insulation is equivalent to around about several 100mm of conventional either rock wool or extruded polystyrene, etc. So all that shed is doing at the moment, apart from some sensors we've got externally and internally to monitor temperature, is just that. So, and to make it even worse, we're down in a dip, we're in a hollow, so it can get particularly cold here. Outside temperatures have gone as low as -20. We've decided deliberately to float it on the lake because obviously water makes it even worse, and what we've seen from our results is basically this insulation does do what it says on the ticket. It's an incredibly innovative product, expensive at the moment, but if it can be scaled up and we can start using this, not for new build, that probably wouldn't be economically viable, but for existing properties, listed buildings which can't benefit from insulation externally, such as Cotswold stone properties or the Lake District, where you won't get away with putting external wall insulation in. This product could be applied to the inside of the fabric of the building and produce basically passive house standard buildings. So basically this product, aerogel, 10 to 12mm thickness, can take any old structure, any old building, and take it to passive house standard, or if applied to the inside face of that structure. It's vapor-proof, it's waterproof, it serves many purposes, and it'd be great to see this product upscaled more commercially so everybody can benefit from this technology.
20 years, or 15 years ago, no one knew where this technology was going. That's the problem. So when you're given the challenge to sort of plan for the future. I hate the word future-proof. There's no such thing as future-proof because I haven't got a crystal ball. I can't tell what that is. So you just flood the house with Cat5 and Cat6 cable. You flood it with the cable to various locations where you think it may be needed in the future. And it's just happened chance for us. It's worked out. Because every time we come along with a new technology to put in, we've got a cable to do it. Like down here, like putting the lakeside building on. And we want to do temperature control in the building, we want to do light control in the building, we want to do music. It just happens that we've got connections down here that we can now piggyback to and do it. So it wasn't foresight, it was just not knowing, and therefore flooding the house with cable. That's pretty much all I did.
So we're going down to the basement to see my favourite bit of technology, which is the sewerage system, which we call is the Aquatron unit. So we're here at the basement of Moonstone, where I think I got what I believe is my most exciting technology, which is an Aquatron unit. What we're looking up here is a chamber. The Aquatron unit is this device up here. We're basically flushing our toilets, our showers, our dishwashers, our washing machines, all what we call black water is coming down these pipes through into the top chamber of the Aquatron unit, and by a very simple mechanism of the water spinning around, creating a centrifugal force with all the poo and toilet paper and stuff, the solids get dispensed directly into the centre of the chamber. The black water, which is your wastewater, dishwasher water, everything else, that goes down this grey tube and goes down out towards our reed beds, and the reed beds filter all that water to drinking quality standard water in a matter of weeks. And then we recycle that same water back up to our 20,000 litre storage tanks. And what do you do with all the poo and stuff in here? We haven't got smell-o-vision, but just reassure you that it doesn't smell at all. There's a slight odour, but it's nothing. We are in the back of our cinema area underground. And to demonstrate what actually happens, in this chamber are 4 chambers which get rotated every 3 to 4 months. There's worms in those chambers, and they munch their way through all the solid waste, because there is a little bit of water waste. Probably this recovers probably about 90% of the 95% of the water, leaving a small residue of water which drains to the base and then disappears off the reed beds. So let's have a look at what happens to poo. Let's hope I don't get this wrong. So principally we have our poo, which is the sediment you see at the bottom. I won't handle that because that is actually poo. That's the first chamber around from last year, and as we rotate the chambers round, we can see what we end up with, which is this chamber. This chamber is, so that is compost basically. That is basically poo, which has been dried out, eaten by worms. So basically that compost is then taken by buckets through the window and is dropped onto our veg patch. We've done that once since we've lived here, so for 15 years this has been turned on. We've only emptied it once, so I'd say every 7, 8, 9 years we have to empty these units. And what a simple solution. No Thames water connection or main utility connection at all. Recycling all the what we regard as dirty water, which is filling up all our septic tanks, and that's the element which needs to be treated. So when you see the processing of sewerage, if we take the black water away from sewage, with solid sewage, we do not need to process it expensively the way we're doing it at the moment. So this is a very sophisticated, if you like, worm composting pit. Job done. So leading into our plant room, we're now totally underground. So what we're seeing here is T collector is the temperature at the top of the big panel. So it's approximately 4 o'clock in the afternoon. We're not expecting to be very good. 42 degrees of heat is being generated currently with a dull day in early November 2020. And then we're pumping that 40 odd degree temperature water into our heat pump and into our tanks. So what we saw earlier on with the large solar collector, very simple technology, solar thermal collectors at the top, 50 square meters approximately, and that dumps down into these 2 huge Thiessen stratified tanks. I won't talk about all the information. This is a Thyssen Austrian product. There's approximately 3,000 litres of hot water storage in each tank, so we've got 6,000 litres of hot water storage. We're currently in the plant room, and it's currently recording a temperature, even inside the plant room, of 26 degrees, and that's despite all the insulation that we've got in here. So this room itself gets very hot. Other technology is, if solar thermal isn't working, so it's a completely cloudy day, December, January, really bad, then what we do then is we have a very small single-phase NEB heat pump, which basically generates backup heat coming from slinkies, which are coils in the ground, and boreholes which go down 60 to 70 metres in the field and our surrounding land. Now that barely comes on. Currently we're using it as a mechanism for taking water, pumping water around the house, and we're currently showing 50-degree temperature when it's a dull day. It's 4 o'clock in the afternoon. It's also light levels are poor, and all this extra heat is now going to the swimming pool. So the beginning of Moonstone, it was very difficult to decide which technologies we were going to invest in. Principally, the whole point of Moonstone was about investing in what really counts, which is the fabric of the building. So insulation levels were incredibly high. Talked before, 0.5 metre plus of insulation in the walls using extruded polystyrene, which is around about 1 metre worth of rock wall insulation. When it comes to the technology, I very much wanted the latest kit, and I was very fortunate enough to meet up with Kane from Virtuous Integration at the time, or JK Audio they used to be called, and we installed these racks. Now initially, both of these racks were completely full of flashing lights, black boxes controlling things like HDMI distribution, DVDs and stuff like that. Well, we've moved on a bit. 2002, 2005 when we spec'd it, of course it was DVD players, it was Netflix wasn't even an option. That's all moved on, and consequently, just to show you what's happened, so when we started the project we had 2 racks full of equipment. We've now actually got a quarter of that, so the only technology working today is here. So from down here to here, and this is much more advanced than the technology that we initially installed in the property. So it controls the lighting systems, heating, doors, gates. You can sequence everything with Control 4 as a product. Control 4 is also an adaptable product, so you can add things, customize things, sequences of lights, irrigation, anything with Control 4 basically. It's a unique system. I'm very lucky to get it in, and it saved me a small fortune on the systems at the time, which were AMX and Creston and other systems. I guess one of the principal things we did with Moonstone, or Kane convinced me to do, was to make sure the whole property was heavily cabled. So we used a lot of Cat 6 shielded cable throughout the entire property, which then therefore meant we didn't have any redundancy in the system at all. So the cables, we ran we ran Cat 6 cable everywhere throughout the property, which allows us to expand without damaging the fabric of the building anyway. So the whole swimming pool is heated with solar, and we've got too much of it, so that's what I'm saying. So basically we weren't quite sure if this technology would work or not. We constructed a large triple glassed cube across the swimming pool. Now principally to try to demonstrate the passive solar gains that you can get from a property. So this is due south, it's facing directly into the sunlight. Again, it's 4 o'clock in the afternoon, early November 2020. So the property is well insulated, it's got triple glazing. The idea here is your swimming pool behind the glass box. By the sun, purely the sunlight on its own, no clever technology, we can heat the volumetric part of the air and also get a tiny bit of passive solar gain to the actual water itself. It obviously doesn't heat the entire pool for free, and that free heating then comes directly from the solar thermal panels that you see at the top. In fact, so much so as we create far too much heat in the swimming pool. So it's a bizarre situation, we have to cool the air down. And the trouble when you create too much heat within a glass cube is you get a lot of condensation. So we actually have to cool the water down, and to do that we use this device called a heat star. So again, here we are in November 2020, and we are registering a water temperature, which is for free, 31 degrees, an air temperature within the side of the glass box of 30. Now it's not working quite right at the moment, that's just gone up actually, it's 32. To create the humidity right and the reclaim levels right, we've got to have the air temperature about 1 degree to 2 degrees above the water temperature. So right now this device isn't coping with the excess heat we've got, but this unit is an air conditioning unit, an air source heat pump if you like, which is taking heat which we create too much of and trying to cool it down. So this is one of our advanced smart metering systems called eGauge, which we've had since 2010. This basically shows today's date, which is November the 12th. It was a very cloudy day, 12 o'clock in the morning, early hours in the morning through to 6 or 7. Obviously we're not generating anything, there's no solar thermal, there's no PV. As soon as we get to 8 o'clock, we get to a massive spike where basically the red line is showing consumption. The green, actually the red just drops off the scale. There is no red until about 12:30 when I probably put the kettle on if I looked at that. The rest of that is just all excess electricity being generated from Moonstone. So it's absolutely massive. So as we've discussed already, we create far too much heat. So we can duct the heat, but then what do you do with the heat? You've got too much for the pool, we heat the pool up too much, and then consequently we have to cool it down. So unless we were to use something clever like a phase change material and actually be able to store the heat, or get the heat to such a level that we create a steam engine, and from a steam engine you can generate electricity, but we're already producing too much electricity, so we can do fun things like this. We have lucky enough to have an industrial unit, we can duct our heat through to look after these fellas. So in summary, what have we actually learned here? We are now charging an electric vehicle with free electricity, which we're being paid by the FIT tariff to charge our car. So this car has not cost me a single penny since we invested in it back in November 2019. And most importantly, and more recently, in May, a wonderful company called Octopus Energy were paying us to actually charge our car. Actually paying us to do it. We've already talked about aerogel, which is this very expensive product which we can retrofit to any existing listed building or property which doesn't allow us to put external wall insulation on it. But we have also, one of my companies is called swindonstudios.com. 10 years ago, just after we finished the Moonstone project, we used internal wall insulation and external wall insulation to clad some 1920s, 1870 buildings and make them energy efficient, so much so that our tenants do not pay any bills. So they pay no gas bills, no council tax, no water rates. Electricity is purely on demand. We can make their properties energy efficient. And most importantly, it's all very well having a huge house, because people can turn around to me and say, how do you descale it or minimize it? So we have already produced container homes, which are these steel container units, clad them with our wonderful aerogel technology, strap them with solar panels, strap them with an Aquatron unit, and we've now got a system for less than £10,000 which basically produces a solution, I personally believe, for homeless people. So a £10,000, sub £10,000 container home which is off-grid. Moonstone was designed to say, a huge building, how can it possibly go off-grid? Now we've demonstrated that today. Moving into the future, where you can use 3D printed houses. There's a wonderful company which we're in a relationship with, called Wasp, which prints a 3D house with cob and earth to create the sustainable passive house structures for less than £20,000, totally off-grid. Exciting.